We didn't do any of those boxes underneath, correct? Did any of you try them on your own yet? No? Oh, okay. Who should we go with? We need to call on somebody that did not get called on yesterday. Gabe. You didn't get called on yesterday, I don't think, right? No. Perfect. Okay. Do you think you could come on up and walk us through how to do box C? And we can help you out if you want some help with it. So we took the time yesterday, we were given this table of f of x and g of x, and we went through and figured out some values for f inverse and g inverse. And now we're kind of being asked to do composites of a combination of all of it. So on C, what's the first thing you're going to try to figure out?
The inverse at x equals 0.
Perfect. Okay. So that is 1. Good.
And then you do
F of 1.
is -1.
Perfect. I mean, that's kind of how you walk through it. It, I would say for the most part, it looks, thank you, that's perfect. It looks kind of imposing when you're first just given that information, like asked to find this. But if you take it little by little, it's not too bad. The main goal of this is for you to kind of learn how to look up the information with what you're given. Do you guys think you could try D, E, and F on your own? Or do we need to do one more together? Okay, try D, E, and F. Because if you can get these bottom 4 down pat, then that means today's formula would be pretty easy. Ellen, do you want, whenever you get done with, oh, did I butcher that?
What?
Did I butcher it?
No.
Oh, okay, good. Whenever you get done with D, do you want to head up there and do that one?
Not particularly.
What? Why?
It's a little scary.
The board?
Yeah.
Do you want a little emotional support person to walk up with you? Because that definitely helps. Still no? Is it acceptable if you tell me what to do?
What if you just find f of -1 and then find the inverse of that?
I mean, yeah. Did you do that?
I don't know.
I'm not sure I can answer that for you either. So what's f of -1?
4.
Okay.
Or is it 1? I don't even know.
Okay, so f of -1, regular f is up here, that was done. Regular f is up here, f of -1 is 4, like I said. So then we would say f inverse of 4. And then f inverse is over here. F inverse of 4, -1. Now, I don't know if any of you are felt comfortable doing this yet or not, but theoretically we don't need these 2 boxes at all. Like if you're given this information to start with, That's actually all we need, but I know you might not be comfortable doing that yet. So when this says F inverse of 4, well, then that would tell me to find when F has an answer of 4, and its answer would be negative 1. So it's kind of like reading the table backwards. That's all we did when we did the inverse to start with. E. What was it? Oh, I heard you say it would be 2.
Well, we're not sure if we could decide it to be 2 or not.
Oh, where are you stuck at?
Well, we were just thinking, because since 3 isn't given X value,
Where are you getting 3 from?
so the inverse, or the G inverse of -1 is 3.
Okay,
And so then if you're using that 3 as the X value for the inverse F, there's no.
right. They don't give you enough information to figure it out. You can write it however you want. I didn't want to put doesn't exist because we don't know. It might exist, we just weren't told it.
On the test, could you just answer F inverse of 3?
You may like leave this as the answer?
Yeah.
I don't see why not. I'm not gonna give you one on the test that doesn't work. I should put it that way. Like, this was just kind of thrown in there to make sure that you're not just like grabbing answers or, you know, whatever. Okay. Steven, no, you went yesterday, didn't you?
Yeah.
James, did you go yesterday? Excellent. You think you can help me with that?
Yeah.
Okay,
So you do F, which is 4,
okay,
which is -1.
good.
And you do G inverse of -1, which is 3.
Perfect. Okay. Once you get the hang of these, they're not bad. I mean, like, once you get used to figuring out where to look, there's not much more to them than just regular tables and functions. I would say the part that's the most confusing, whether you consider it or not, is just the notation. This wasn't terrible because we didn't have primes. Once you start having primes and inverses together, it's a lot of symbols, and you kind of got to keep it straight what's what. So let's go to here. I'm not sure if we're ready for this or not, but we're going to go for it. We kind of started it yesterday. So given f of x equals 4x minus 3 and f prime of 2 equals 4, find the value of, so this person that writes these notes writes it slightly different than how I've usually ever seen it. Not that that's, you know, bad or good, it's just, this one's probably a little bit clearer. F inverse prime of 5. Now, at first glance, this seems kind of horrible because none of these numbers necessarily seem like they have anything to do with each other. Do you remember what we did yesterday when we drew the picture? I can't remember who in this class did it. Who had to draw the picture yesterday? So if you've got inverse drawings, we looked at the fact that their slopes were just flipped upside down from each other. Now, the main key part of that is that these locations where the slopes are flipped are also the inverse locations, right? They might not necessarily have the same numbers, but their slopes are going to be flipped upside down. And I can't remember if we even got to talk about why that sort of made sense. If you think about what slope is, it's change in y's over change in x's. Well, when you find the inverse, you switch the x's and y's backwards. So if you do that with the slopes, they would flip upside down. The hardest part is that you're not going to have corresponding numbers. Like, the numbers aren't going to just like directly make sense. So here's how I'll try to do this one with you. There's two ways to do these questions. This is one way. This is the way how to do it without a formula. I think for some people this makes sense, for other people this will not. Some people will prefer the formula on the next page. So we've got our function. And this one's easy enough, we could actually technically figure out the inverse on it. But we're not gonna do that. So then it says, given f prime of 2 equals 4. And this is probably where the jump happens that might not make sense. The part that we skipped was f of 2. Because remember, our slopes have to be at corresponding inverse points. So we actually have to figure out the point that this slope is at first. F of 2 would be 5. So its inverse location would be at 5, 2. Instead of 2, 5, F inverse of 5 would equal 2. So these two correspond together, those two locations. We were asked to find the slope at 5. So that would be F inverse prime of 5. Because these locations go together, their slopes also do. So if this slope is 4, this slope is upside down. That's kind of like the picture we drew yesterday. The picture we drew yesterday, they were inverse graphs, and their slopes were kind of tied together, but upside down. So this is one method, and I would bet for some of you this kind of makes sense, and for some of you this made nothing. And that's what, I'm like, don't feel bad if this didn't click at all. Does anybody want me to run through this again, how I set this up? Probably? Okay. Now that you've got it written down, you can just like watch it fresh. We were given the equation, and we would have to have something from that anyway. But so we were given the equation, and then it gave us the derivative at 2, okay? So I put that down. But the fact that it's talking about the derivative at 2, the slope, means that I need to know the point at 2, the location. So I had to figure out f of 2. Sometimes you'll be given that function information, sometimes you won't. This one I just figured out because the equation's there. So f of 2 is 5. That means its inverse point would be 5, 2. That's over here. So these 2 points are tied together, which means their slopes are tied together. If the slope at the original point was 4, that means the slope at the inverse point is going to be flipped upside down, which is 1/4. So that's one method to find the derivative of the inverse. Second method is that. Clearly the worst part about this is actually knowing the formula. So some people like formulas better. So this says the inverse derivative at a number is going to be 1 over the derivative of the inverse value, which is actually what we did on the other page, but this is the formula that says that. Okay. Now we get to the part that annoys me, but it makes sense. See how on that first page we had a table of f and g, and we also had f inverse and g inverse. Well, they try to make it easier for you by not having so much notation flying around. So frequently, they'll tell you the G is the inverse. And if you're told that, then you know it. So instead of writing F inverse, they're just gonna write G. And to me, that's super annoying because sometimes G is just an equation on its own. Sometimes it stands for something, you just have to be able to read everything. I personally don't mind writing F inverse, but you're gonna be given the problem lots of ways. I guess that's my point. Okay, so it says find G prime of -1. So that up here, wherever it says F inverse, I would do G. Because G is the inverse. So if I'm gonna fill out this formula, G prime of -1. I mean, the advantage is that you can write prime, and it's not gonna be confusing with the inverse. Okay, formula says it is gonna be 1 over F prime of G of 1, -1, sorry. How do we figure out G of -1? What does G stand for? G is the inverse points of F. So if I want to find G of -1, I need to find where F is equal to -1. Because F and G are inverse, I need to find where F is equal to -1. That's the same thing as plugging in -1 into its inverse. So that would be right here. So G of -1 is 3. That's probably going to be the hardest part about the formula by far. Depending on how you take notes, I would definitely write a note to yourself in there about how to find that answer. Like, you're gonna wanna put some sort of note to say that that is where F is equal to -1. You know, however you write it to yourself. And then F prime of 3, I can just go from that table. Normally, we're gonna have equations, so a table's not really gonna be the thing. But this one, F prime of 3 is -4. So it's two very, very different methods to find the answers. Do you guys want me to walk through this one again at all there for you, or, I don't know, ask questions away? Does this feel horribly confusing? Does not. Oh. All right, I feel good about how I presented it. I guarantee it will feel confusing though, so, I mean, like, don't feel bad when all of a sudden you look at a question and it feels completely different. I'll just keep going on. I mean, like, that's why I'm asking. Let's try to do one with an actual equation. It says, let G be the inverse of F. Okay, so as soon as it says that, I am not gonna write F inverse, I'm gonna write G. Calculate G prime of -9. Do you guys have, I should have asked this already. Do you have a preference for which method you like doing?
I like the first one.
Oh, really? Okay. Or is this gonna be a 50-50 thing? Yeah, it is, okay, I should have just expected, it's gonna be half-half, that's all right. We'll do it both ways. I'll do the first way first, and then I'll do the second way second. Okay, so I've got calculate g prime of -9. So in my brain, the way this works, I'm gonna have regular function values, regular function derivatives, inverse values, inverse derivatives. This says to calculate the inverse derivative of -9 as my ultimate goal. That tells me that I need to figure out the inverse at -9. What would that mean for f? If I'm plugging -9 into the inverse, that means f would be equal to -9. F of something. So I need to figure out when that equation is equal to -9. I will tell you, you're not gonna get any crazy hard questions in this one. These are all gonna be set up so they work out for you. And if they don't, it's a calculator question, which you wouldn't have to figure out by hand anyway. So off on the side, I need to figure out which x value would give me -9. On the AP test, this will only be given to you if the answer is 1, 2, or 3, or -1, -2, -5. It is not intended as something you have to actually like solve, like factoring or something. They're gonna be plug and play, like, just try them. Guess and check. If I plug 1 in, it wouldn't work because 1 would give me +9. So that immediately tells me in my brain that -1 will work. Because if I plug -1, this would be -4, -5, become -9. So the answer is -1. Over here, this is the x value I needed. That means I'm going to figure out the slope at -1. Okay? That's going to happen by me calculating the actual derivative. What is that? 17? Because I figured out the slope at the function point was 17, the slope on my inverse point is going to be 1/17. So that's kind of like the first method on how you calculate it. And now I can I'll certainly go through and do the formula way, which honestly is going to have the exact same information. So the formula way is the inverse derivative at a number is going to be 1 over f prime of the inverse of that number. So instead of me writing f inverse, we write g. First thing I have to calculate is g of -9. So g of -9 means where f is equal to -9, which surprising, like, it's gonna be the exact same steps as the first one. I need to figure out where this was equal to -9 first. That was at -1. So g of -9 was -1. I mean, that's what we figured out over there. And then the next thing is to find the slope of f at -1, which we calculated was 17. formula is the exact same steps as the first method, just written in a formula.
Wait, where did you get the 17 from?
I erased it because it was behind that. I had to take the derivative of f because we were given f. I ran out of room. 12x squared plus 5. And then if I plug in -1. That's where it's going. What I expect to happen is when you guys are doing this homework, it's not too bad. What usually happens every single year, A, you're gonna completely forget this formula. It's the only time this year we use it, and it's not used any other time, so you basically completely forget it by the AP test. It's partially why I like that method, because just for me, when I learn methods, like when I learn how to do something, my brain remembers it a lot better for some reason. Where if I try to just memorize formulas, for me, all the formulas start to get mixed in my head because they all have similar parts. And I like that method for me just because I learned how to do things better that way. But I also know some of you are excellent at just memorizing facts like crazy. And so you're probably better off doing a formula or something. And it's very possible that if you don't do any of these until Friday, you might forget how to do them by Friday. So that's partially what I'm worried about. I think you'll actually be really good at them today because it's the exact same steps repeated. It's just that it's difficult to remember them because nothing else in calc is going to be like these steps. So I don't know. What do we have? 20 minutes? Okay. Is there another one on the next page, or does the next one go immediately to the other bases? One more? Should we do that one?
It says you need a calculator.
It says you need a calculator. That's terrible. All right, we can do that. You guys all have calculators, Chromebooks, phones, whatever you need. So the calculator is only going to have one difference, and that's when you're trying to figure out when this equation is equal to a number. That's the only difference between the two different methods. Do you guys think you could try this one on your own? Or are you going to need help with the calculator part? I'll help you with that calculator step, and then I feel like you can do the other steps on your own. There's different ways we can set this up. I know some of you in the past like using the solver. Isn't that like under apps or something like that? One of the science teachers teaches to use the solver a lot. It doesn't work well for calc though, so try not to use solver at all for math. So we're gonna basically just use the graphing portion to help you figure it out. On this particular problem, we need to know when this equation is equal to 3. The way I do that on the calculator is I need to type in both equations separately. 4x7 minus x squared. Plus x minus 5. So I want to know when this equation is equal to 3. And there's different ways to set this up and to solve it. So if you know your own method, go for it. That's going to be the same. I want to graph both, and I want to figure out where they cross. That's how we know where they're equal. So I'm going to use the calculation menu that says where they intersect with each other. the x value is what I'm looking for. First curve is blue, second curve is red. I need to put it about where they cross. So then 1.106 is the x value you're gonna use for the rest of the problem. The only difference on these calculator ones is how you come up with some of the answers. You still have to go through all the exact same steps. But I was also guessing some of you probably forgot how to use the calculator a little bit. Yes? Do any of you guys use Desmos instead? So Desmos, you would still graph the same two equations, but I believe Desmos, it kind of automatically has like a point where they cross. And if you move your cursor by it, I think it just pops it up. Is that right? Okay. Knowing how, I mean, there's definitely nothing wrong with Desmos, except that you're not allowed to use it on the AP test. That's really the downside to Desmos. I wouldn't be shocked if within a handful of years they figure out a way to use Desmos on the AP test, because a lot of people use it because it's free. But the only stipulation they have on the AP test is you're not allowed to use a calculator that has internet access. And since Desmos is internet-based, they don't let you use it. So I'm guessing sooner or later they'll have a Desmos-based device that has no internet access or something, so that you can use it on ACT and AP and stuff. See if you can go through and finish the rest of it then. That's not domain. That's dimensions. Oh, it's trying to plot the numbers you no longer have in your calculator. So you're trying to turn that off. Justin, are you feeling pretty good about number 5?
Not necessarily.
Oh, I was hoping you were going to go up and do it.
Give me a second.
I can definitely do that. I'll give you a lot more than that. I guess I should have asked you if you like using the formula or the method better, but I thought I would put the formula up here if that helps at all. When we did the calculator, we were trying to figure out f inverse of 3 when we made them equal to each other. So on the bottom, it should say f prime of 1.106. Oh, wait. Is all the calculating I'm seeing, did you do the derivative and then plugged in 1.106 by hand?
Yeah.
Oh. It's not wrong to do that, but it definitely is very slow. So because this is a calculator question, you were trying to do the derivative of f of x, right?
Yeah.
Okay. On your home screen, you can tell the calculator to do the derivative, number 3. And then instead of typing the equation all over again, you can tell it to use y1. The easiest place to find that is F4. Did you guys go through the new menu? Do you want me to start over because you have no idea where I was typing stuff from then?
Sure.
Okay, my fault. Clear, we'll start over. So depending on the TI-84s, some of the new ones act like, if you have one that has a little fraction symbol right there, it's like one of the brand new calculators. But otherwise, all of them have 4 menus that they don't tell you about. And they're basically all the menus we use in Calc. So you have to hit alpha to get to F1 or F2 or F3 or F4. And they're not labeled in any which way. But if you hit alpha and go to them, it kind of, on your screen, it tells you which button does what. So the first one is how you can type fractions in the calculator. Rather than using a parentheses and division symbol, you can just do fractions. The second one is all of the different functions that are the most commonly used in higher classes. The one we wanted was the derivative one. That's how to find the derivative at a location, nderive. The third one you'll probably never use unless you're taking the ACT, and that's for making matrices. But the fourth one looks totally useless because all it does is have y variables, but that's really helpful to us. So I want to go back to the second button because I want to do a derivative. And I want to do ddx. I don't want to retype that whole equation for y1. Some of our equations this year are going to get to be super long, and you don't want to retype them. So this is where you can use that variable menu. If I hit number 1, that's just going to tell the calculator to use the equation that's in y1. And then I don't have to retype it. And we're trying to find the slope at 1.106. So then I would just need to type in the number 1 time. Now there isn't anything wrong with what you were trying to do, but you did the derivative by hand, and then you're plugging in 1.106 repeatedly. It is correct. On the AP test, the goal on everything about that is speed. So if there's shortcuts to anything, you kind of want to know them by then. This is definitely going to be one of those type of shortcuts. I just want to know the slope of this equation at this number. Rather than me finding the derivative by hand, typing it in by hand, I can just tell it what to do. And you would have got the same answer. It's not like it was difficult. But learning to use your calculator efficiently is a huge help. So what was your final answer then, now that I kind of took it over for you, sorry.
The derivative, 50.03.
So what would be the final answer to the question? Where did that 50 go in the formula?
The bottom, so 1 over.
Yep, perfect. So the final answer would be 1 over 50 and change. Honestly, I guess since it's a calculator question, you probably wouldn't leave it like that. I guess you would probably just calculate it out. So I want I want the inverse of my answer. So I guess it would be 0.0, ooh. I guess 0.020. They wanted 3 decimal places, I believe the direction said. So 0.020. Do you guys know how to use that inverse button? The inverse button is finding the answer to 1 over. Okay, I'll stop there. I mean, like, this is all the farther I wanted to go in the notes. There wasn't many examples. They're just super slow.
When are we gonna know if we need to memorize all of the derivatives?
Oh, tomorrow. We're meeting tomorrow morning to figure out which day we want to do the test on.